Good morning. We're doing it most missed questions for week 10, or is it a different one?
Should be week 11, but did he send it? I don't think he did. Right? Shouldn't it be week 11?
Yeah, last one I've
It's like,
seen is week 10, so
yeah. Also, have you gotten your quiz 10 back? Because that would be the
yeah,
quiz.
or whoops. Hmm. Doesn't sound like it. Doesn't look like it.
Well, might be a short meeting.
Yeah.
Let's see. I don't think he posted them on iLearn. He hasn't been doing that really anymore.
Mm-hmm.
Should we email him?
Yeah.
Okay, I'll shoot him an email. Okay. Yeah, and I don't have my quiz back yet, so we can't talk about that. Do you have yours
Yeah.
back?
I don't think so. No.
I think his TA quit because I haven't
Oh.
heard anything from the TA. The TA is the one that's supposed to do the quizzes, and lately Brother Soleil has been sending them. So I wonder if his TA isn't doing it anymore.
Yeah, that would make sense. My quiz has been graded. I remember there was one that I really couldn't do, but I got my grade back. So
I got my grade back as well, and I did a lot better than I thought I
yeah.
would.
I got like
I
a
think
D plus. Like that was a sad day, but
oh, that is sad. That's what I got on quiz 9. I got a D, but on
yeah.
quiz 10, I got an A.
Mm.
Well,
Oof.
I guess we can just wait a second to see if he emails back right away. He's usually really quick at responding to emails, so
He is, yeah.
I suppose we could just, even though we don't know what ones we missed, we could just look over our week 10 quizzes and like discuss any questions that we had.
Right. What you think would probably
Yeah.
and whatnot. Okay.
Oh, interesting.
Okay, how long did it take you to do everything this week and the homework?
This week, I like the lessons this week.
Mm-hmm.
I haven't done them all yet. I did lesson 1 and 2 yesterday, and I only did 70% of each one because I was like,
Yeah,
2 hours per assignment is plenty, and I've got enough practice, so I'm done.
yeah, no, it took me forever to get them all done.
It kept being like the wrong answer over and over and over again.
Really
I
bad.
was like, I understand this just fine, but I just can't get the right answer.
Oh man. Yeah, no, it takes so long. And like it gets more and more complicated as you go along, you know?
Yeah. Yeah, definitely.
Like,
Okay. Oh, go ahead.
sorry, I was just like the first three questions of each one were like for some reason no help me on this, but the rest of them were. So it
Yeah.
took me a while to figure out to just skip those and then come back to them, you know.
Yeah.
And like now I
Yeah.
kind of understand how to do everything, but like then again, what I'm still phased
Yeah.
from this week.
I haven't tried lesson 3 and 4 yet, so we'll see how that goes.
Yeah.
Okay. Well, should we look over our week 10 quiz?
Yeah.
We can even just like compare answers and then we'll figure out which ones we got wrong.
Yeah. Go. We want to go over week 10 quiz or week 11
I think it
or
would be
week
week
10 quiz.
10, right?
Yeah,
Because the
we
like,
don't have week 11.
yeah,
Mhm.
questions are from last week. The quiz is from 2 weeks ago.
Right. How do you think you did on the quiz? Did you get, or how do you think you did on the exam? Did you get your grade back?
I don't think I got my grade back yet. I I don't know. I'm trying to remember how I felt about it. Let me
Yeah.
check if I got it graded yet. Oh, I did get it graded. It was exam 3, right?
Yep.
I got a 94. Woohoo!
Dang, girl. For some
How
reason,
did
I always
you?
get like a low B every time. Like all my exams are like that. Like,
Man,
yeah, that's great. Good job.
thanks. Pretty happy about that. I feel like this one was harder than the other two have been.
Yeah.
Okay. Do you have your week 10 quiz?
Pulling it up, trying to find it.
Okay.
Seems like I haven't saved it.
While you're doing that, I'm gonna run change a diaper really quick. I just heard him make a big poop.
Good job. Good idea. So I've been looking around. I don't think he sent me my week 10 quiz.
Oh, so he didn't send me mine either, but I just have it from before, so we could like
Yeah,
compare that. Do you have that?
I think so. Yeah, I can probably. Yeah, or I should. Should be somewhere. And that's like I feel bad because like I didn't really know, but like isn't that one that we're supposed to have corrections on already?
What was that?
Are we supposed to have corrections for these already or no?
Oh, what do you mean? Like,
Are we supposed to like
are we
have
supposed to have ours back by now, or like have submitted this one?
are we supposed to have like done the quiz corrections for this? Like
It's due Saturday.
it's due, oh, so this one's due Saturday. Okay.
Yeah,
I was confused because it's like the week before.
yeah.
I'm losing track. I'm okay, yeah. Um, okay.
Yeah, I just double checked. It's the week 10 quiz corrections that's due on Saturday.
Right. Okay. I'm there.
Okay. Um, should we just like go through every one, or should we just go through ones that we think we had questions on?
Let's just go through see if we got the same answer and then go from there.
Okay. Okay, for number one, for part A, I got 2xz e to the y plus y, x squared z e to the y plus x squared e to the y.
Yeah.
Okay. B, I got the square root of 6 over 2.
I did not get that. I got 1 plus ln 3.
Oh, those are like way different.
Yeah.
Um,
What'd you get for each partial? Or yeah, what did you get when you plugged in the point for each for the gradient?
so I got 12. Well, okay. When I plugged into the gradient, I got 12, 6, and 3.
12, 6, and 3. I
Yeah.
got whatchamacallit, looks like 6 plus ln 3, 4, and 3. So the first two are not yours. What was the point again? It was 1 ln 3, 1.
I had one ln 3 too. Is that? But you know what? Oh, I must have forgotten to add. Oh, I totally
Plus,
got this wrong.
yeah,
Because you add y in part A, and y is ln of 3. So yeah.
right. And did I get the point wrong? Because I could have very well gotten that.
The 1 ln 3 2, is that what you're talking about?
Yeah, because if it's 1 ln 3, 2, then I probably got a lot of stuff wrong too.
Okay, let's go back and look at the original quiz, I guess.
Right.
Uh,
10 gradient.
Have you noticed that there are a lot of typos on the like website one, but the print friendly one has like the
Yeah.
it's
Yeah.
so annoying because some of them are like a big deal. Even the
Right.
exam, there was typos on the exam on the first
Yeah.
problem. They all said like the partial derivative with respect to x, and there was only 4 of them instead of 5.
Mm-hmm. Yeah, it
Okay,
was
yeah. The quiz says 1, ln of 3, and then 2.
okay. So I got that part wrong.
Okay,
I think I did the work right, you know.
right.
So it should be 2 times 1 times 2 times e to the ln 3. That
Which is
would
times
be,
3.
yeah. So that would be 12 plus ln 3
Yeah, okay. And then the second point,
would be 1 squared times 2 times e to the ln 3. So that would just be 6 plus 1. Yeah, like the
yeah,
partial or the second component would be 7, I think.
I think you're right. I missed adding on all of them. That
Yeah.
sucks.
So that
Okay,
makes sense because the last one he didn't have to add anything.
all right.
So I totally see you did everything right except for that little bit. Because we both got 3 for the third one. That one's pretty self-explanatory.
Okay, so it
So
should be
12 plus ln 3 and 7 and 3.
okay. Okay, and then I'm sure going from there we would both get the. What did you get for u?
U was 1, -2, 1. That's what I.
Okay, and then you also have to divide it by its own magnitude.
So the directional U. Got you.
Because it's a the u is because it's a unit direction vector. That's what the u stands for, is unit, and so you have to divide by its own magnitude.
So U is 1 over root 6, -2 over root 6, and then 1 over root 6.
Yeah.
You can make those in a better form, but as right now it's good the way it is.
Yeah.
So dot product.
Okay, I got 1 plus ln 3 over root 6.
Yeah, I got that too.
Okay, cool.
Cool. So funny thing is I got like 1 plus ln 3, but it should have been 1 plus ln 3 over 6. Over root 6.
Oh,
It's funny how I got so close, you know?
that is funny. That's awesome.
Alrighty. So that one seems good. 2, or just 1 part for this one, or 2 parts? Was it just 2 parts? Yeah.
Well, I have an A and a B.
I probably have an A and a B somewhere, but like I'm only seeing that A. Where did I put my B? Oh boy. That's funny. Um, so for A, what did you get?
So I got the square root of 86 over 43, negative square root of 86 over 86, and 9 square roots of 86 over 86.
Cool. I got that too.
Woohoo! Okay.
Oh, and part B was just finding the derivative at that point. The direct.
Yeah, I think so. So it's just plugging stuff in. So I got square root of 86 over 3.
Hey, same here.
Woo! Hopefully that means we're both right.
Right. You ever see Kung Fu Panda back when?
What?
You ever see Kung Fu Panda?
Oh, yeah.
Yeah, no. You remember that part of the end? Just like, oh, you're alive, or are we both dead?
Oh, yeah. Yeah.
That for a minute. Oh boy, using the gradient to find the plane tangent. I feel like I did this right, but if I got it wrong, I would not be surprised.
Me too. I don't think that I feel like the homework isn't necessarily good prep for the quizzes at all.
So, what did you get for the answer? The plane equation.
Okay, so I got x minus 1 plus 2/3 times y minus 1 plus 1/3 times z minus 1 equals 0.
Okay. I had that in a different form because I did it in a different way.
Okay.
So I got 6x plus 4y plus z equals 11. That might be the same. It doesn't really sound so. So what did you put? What was your equation again?
X minus 1 plus 2/3 y minus 1 plus 1/3 z minus 1 equals 0. And I guess you did the like ax plus by plus cz equals d.
Yeah, and
So,
using the fact that the normal vector equals the gradient at that point.
oh, okay, yeah.
But
So mine is in like a point slope form of the plane.
right. So 2/3 y plus 1/3 z.
And the way you did it, it could be off by like a scalar, and it's like still an equation of the plane. But
Right.
so if ours don't match exactly, they could both still be right.
I think I might have even gotten like something. I think I multiplied each side by like 6 or something.
Yeah, that makes sense.
Yeah. It would only be by 3.
2. Oh yeah, no, you totally did. Your answer, I think, would be the same as mine, but multiplied by 3. Well, maybe not quite. You got 11 on the other side.
It was, I don't know why I multiplied everything by 6 and not by 3. So I got like 6x with 4y plus z and not 2z. And now it would be looking like 2z or something. So I don't know why I'm missing not even, I didn't mess up with z.
So on for like with the gradient, they had like a special formula in the rating for the plane equation.
Yeah.
For like when you're given this information. I'm trying to remember what exactly the formula was. I think it's okay. So you do like the gradient of the point that you're given, and that's like the slope of each x, y, and z, and then you do within the parentheses x minus the initial point. So since the initial point was 1, 1, 1, it's x minus 1, y minus 1, z minus 1 in all the parentheses, and then just all the slopes out front from the gradient.
Yeah.
At p sub 0.
Okay. And I think I did something like similar to that. I just did the form again. So I put the left side as the I put the normal vector, the vector equals the gradient of a right? That is with the x, y, z.
Oh, right.
I did the dot product of the gradient at the point with the x, y, z point, So it was kind of the same thing.
Yeah.
What was the What did you find for the gradient
The
itself?
gradient?
Yeah.
X, 2/3 Y, 1/3 Z. Wait,
Okay.
does that make sense?
Yeah.
Yeah. Yeah.
X, 2/3 Y, and so the other six. So
One sec. So did you get the same thing for the gradient?
yep. Yeah, you
Okay.
were right. It was just in a different form than mine was, but I don't know what I did. Like I don't know where I went wrong because I got the same thing for the gradient. Um,
Huh. Well,
and I multiplied each side by 6. Oh, that's what I. Oh gosh, I for some reason I put. Does that make sense? Oh, for some reason I put the gradient of. Did I? Hmm. For some reason I put the. I didn't do the z gradient right. I got 1/6 z instead of 1/3 z. So that's where I went wrong.
oh,
Everything made sense from that. So we basically got the same answer. I just did it. Mine's just slightly wrong. So you got it right.
okay. Yeah, that makes sense why you would end up with 1/6 because I had
Mhm.
2/6 at one
Right.
point, and then it turns into a third.
Yep. Yeah. The two cancels that out. Cool.
Okay. All right. Number 4. For A, I got a 2x2 matrix, 6, -2, -2, 6.
Yep.
Awesome. For B, I got 32 and concave up.
Yes.
Awesome.
Dope. Oh, you should see my like. I don't know why. I think I might have gotten really bored doing this quiz. So like I drew it. Like I drew it as part of the explanation.
Nice.
It's really strange. Oh,
Oh, that's a nice drawing.
I got really bored. I think. I don't know what's wrong with me.
That's awesome.
Then yeah. So then for 5, this one took me a little while to figure it out. But what did you get?
I got, for saddle points, I got -2, 3, and 1, 0.
M10.
And then I got 1, 3 as a local min and -2, 0 as a local max. But if I missed one, this is the one that I missed.
True. I might have also did this wrong, but we got the same points. Um,
Oh, just we put them in different places.
I think I might have not done the tests right. You know,
I honestly had no idea really to figure out which ones were maxes and min.
right. Um, so I used the double like second derivative test,
Uh-huh.
but it might be more complicated than that. So, like knowing that the second derivative, like the second partial of x is positive at the places where it's 1, 0, 1, 3, and the places where it was -2, 0, and -2, 3, those were like zeros. So those would be points of inflection, but that's only with respect to x. So,
Oh, right.
but
Well, okay, yeah, okay, yeah, that's what I did too. Here, let me share my screen with you.
okay,
Um, So right here I got, x equals 1 and -2, and then y equals 0 and 3. So we're matching there. That's like the first derivative though, right?
Yeah. So you have to use the second ones, but they had some weird equations, you know?
Yeah, I'm not sure I did them right.
I'm not sure. I just didn't remember the equations. I don't think I wrote them down on the summary page.
I got 18 and -18 for some of them.
Yeah,
So we both got the same
value.
values. I don't know. We'll probably just have to wait till we get our quizzes back to see.
Right. Cool.
I think we both understand it well enough, but
Right.
somewhere. Okay, should we just go to number 6?
Yeah, let's go to number 6.
Okay, for 6, I got. Oh, this is another one of those. I'm also not
Oh
sure if I did
gosh,
it
I
right.
probably failed this one. This is the one I think I might have gotten a really bad grade on.
Oh, yeah, that's not what I got. I got that the max is the square root of 2 and it occurs at plus or minus 1 square root of 2.
Yeah.
And the min is -√2 and occurs at plus or minus 1 -√2.
Yeah.
That doesn't make a lot of sense.
Hmm.
Oh, well, maybe it kind of makes sense.
I don't mind right at all, you know, it's just
Our work looks similar. Like I see in your matrix, you have the same values that I have in my vector. So hopefully we'll at least both get points for our work.
yeah.
And then
Yeah.
6 is the last one, right? That's the whole quiz, I think.
Whoop. Yep.
Okay. Well, is there anything else we like? Do you want to discuss 6 anymore, or is that? Can't see my work very well on this.
Well, I think I think it's fine, but I could use some help on 6. I don't really know
Okay.
the whole process of Lagrange multipliers, you know.
Okay. So let's see. So first of all, the formula is you have L equals F minus lambda G, and then you take the gradient of L, and where the gradient of L equals 0 is where you have the maxes and mins. Yeah.
Okay.
So did you start with that formula?
Yeah, I did.
Okay. So then you end up with a couple of equations. There we go. 2xy minus lambda. Oh, let's see.
Was it 2xy minus 4 lambda y?
Oh, you know what you did? You
What?
just switched a couple of your values.
Yeah.
So you have x squared minus 16 lambda x. I have x squared minus 4 lambda y. And I have 2xy minus 16 lambda x.
Oh, did I straight up switch those two?
I think so. I think you just switched the second value.
So that would be the partials of the ellipse as level curves, you know?
Yeah.
So where did I get the y's? Oh, so the partials with respect to y, for some reason took the partials of the ellipse with respect to x. That's funnier. Okay.
Yeah.
I did that backwards.
Yeah.
So the gradient of the function f of x and y, and at each point is just the gradient, but you have to take the gradient of the ellipse as a level curve, so you have to set it equal to 0 and 8x squared plus 2xy squared. Okay.
Yeah.
I'm understanding this better. So is xy squared and f equals y squared and 2xy. G of xy equals 12 equals ax squared minus 2y squared. Gradient G equals 16x negative 4y. So L equals did I get this backwards?
No, you got the first ones backwards, actually. Yeah, I think I have 2xy first and x squared second.
Oh, I don't know if I did though. So the partial of f minus lambda times the partial of, or so right, um, right in here,
Uh-huh.
this is like when you take the gradient of L, isn't it supposed to be, this is the partial of f with respect to x, and this
Right.
is the partial of g with respect to x.
And the partial of f with respect to x is 2xy.
That's with respect to y though, because it's x
No, the
times
partial with
y.
respect to y would be x squared, wouldn't it?
Would it be? What was the equation for f?
F
Oh
was
crap!
x squared y.
Ha! That's funny. That's why I got these all wrong. So I did
That's
it. I did it
fine.
right. It's just not right. It should be x squared y. So with this equation, this is the partial with respect to x, and this is with respect to y. Okay, that's funny.
Yeah.
My bad.
Okay. So then, after that, for your third equation, you just use g equals 0,
Mm-hmm.
and you solve that system of three equations.
Oh, so g equals 0, and then you have three equations. Okay.
Yep. Yeah. Yeah, so you have
So
those two
yeah,
equations, and then you have g, and you use
that.
that
Yeah.
to solve for all three variables.
Okay. Alrighty.
Okay. Well, I think that covers everything then. Did you have any more questions on this one or anything else on the quiz?
Well, it's kind of after this that I didn't know that you had to set lambda g equal to 0, like lambda g partial, equal to 0.
Right.
So, um, what, like, you just kind of see me failing after that. But like, what exactly?
Oh, he just sent out my quiz. Did you just get your quiz?
I will check, right? Oh, wait.
We both got B wrong on number
We both
1.
got B wrong. Week 10 quiz. Oh, my computer's at straight up 2%. That's probably why it's so slow.
Wow, that's... Oh, wait, no, we already talked about that we both got B wrong. Okay.
Yeah, and it was something small,
Yeah. Okay.
was right. 3 was half right. 4 was all right. 5 was not quite right. What did you get for 5?
Like, what score did I get?
Yeah,
I got 20.
you got 20. So you got it
The right
right.
points, but so do you want to go over that one, or?
I think I just got to look at the rules for the second derivative tests again, or second
Yeah.
partials.
I never felt like it was explained really well anywhere. I think what I ended up doing, well, no. Did you use the eigenvalues?
Sounds familiar.
Yeah, you must have, because you came up with 18.
Yeah,
I wonder if you even just like made an algebra mistake because you got the same value as me. But
probably might have. Yeah.
let's see. So for some of them so for one of them I got 18. One of them I got negative 18. And then for two of them I got plus or minus 18. And those ones were the saddle points, were the ones where I got plus or minus.
Yeah. Cool. And then okay, we got partial credit for number 6.
Well, that's good at least.
Yeah, so I think I know how to set it up, but I didn't realize I must have I made that mistake that we found of the um f of x y. I made that mistake. Like I had the wrong equation. So and I also didn't realize that if you set um like you can take the second derivative, you can take the derivative or the gradient of g, set it equal to 0
Well,
because
it's
gradient.
actually just g before you take the gradient.
One more time.
Well, I guess you take the gradient and set that equal to 0 as well, but your third equation is g set equal to 0 without the gradient.
Right. Mm-hmm. Oh, so you don't set g equal, you don't take the gradient of g to equal 0 because okay.
Yeah, it's just g. So you have two equations from the gradient of L, both of them set equal to 0.
Mm-hmm.
And then your third equation is g set equal to 0, but you don't take the gradient of g, just set it
So
equal to
would it
0.
be 8x squared plus 2xy squared equal what, minus 12 equals 0, or is it
8x squared plus 2y squared minus 12 equals 0. Yep.
huh? How does that work? So that's the limit. That's the
Right. The like constraint.
yeah. I gotta study up on
I
this.
know, I don't totally get why you're allowed to do that, but you are. So, I mean, I
There we
guess
go.
the reason why is because it's still a true equation for x and y. So,
All right. So witchcraft. That's all I'm gonna say about it.
yeah. So he also sent out the most missed questions. Do you want to go to those?
Yeah, real quick.
Okay.
Look at one or two.
They look pretty easy actually. So that's good.
Yeah.
Well, the first one doesn't look as easy, but sketch the region of integration, reverse the order of integration, and evaluate the integral. So
So I kind of got used to this kind of question, and then this week with the surface area of like
yeah,
of a surface and of like a function of three variables, you know? Like that got trippy because that's like to picture you have to have four dimensions, and so you can't really graph it.
I think they said it depends on the problem, but on a lot of them, you can just like ignore the z and just graph it in an xy plane.
Right. Mm-hmm.
Okay. This is kind of a weird graph. It's like such small numbers. Y to the 1/4. What does that even look like? That would be like a really slow parabola, right?
It would be, yeah. I remember my middle school teacher explained all these to us. If you had like the, oh gosh, the not so purest form of like graph of something to the fourth power, it would look like a parabola, but with like two extra critical points,
Oh,
and
okay.
like and a third would be just a graph like a parabola, but one of them's flipped. And
Okay.
as you add more powers, it has more little waves before it goes up.
Oh, really?
And so that's why I could always picture Taylor polynomials pretty easily. And like I understood why you had to use polynomials to like match other functions. Is because they can. They they warp themselves the more powers you add, you know?
Okay, that makes sense. Interesting. That I'll have to think about that some more next time I'm doing Taylor polynomials.
Right. Of course I always like sucked at those. They were just like, what even is life? But like it's hard to do like math with them, you know?
Yeah.
You gotta get them right in the first place.
Okay, so for my graph, I have like the y to the 1/4 curve, and then I have that intersects x equals 1/2 at the point 1/2, 1/16.
Okay. And since it's like y to the 1/4 is just like a really slow parabola.
Yeah.
So
So then,
bounded below by that. And the x. So that would be, it would look like that.
that's what I have, yeah.
Yeah. Cool. Cool, cool, cool.
Oh, wait, hold it up again for a second. Oh, okay, so I shaded it in underneath the curve, but let's see if it goes from 0 to
I put it
1/16.
I put it as the lower. Oh yeah, yeah, yeah. Yeah,
Yeah,
it should be below that curve, but technically to the right of that curve.
right.
Right. I should
Okay.
have seen that. I just, I'm
So,
I just should know that dx dy is just backwards from everything. I should just do everything backwards.
so then dy dx, you're gonna have, okay, so when you switch them, I came up with 0 is less than or equal to x is less than or equal to 1/2, and 0 is less than or equal to y is less than or equal to x to the 4th.
Right.
Is that
Yep.
okay? So awesome. And then to evaluate it, I always plug it in Mathematica because it seems like such a waste of time to evaluate these by hand.
Right. Because then there's like the top function is like cosine 16 pi x to the fifth, which is only like it only goes in like one direction. It's just straight the other way, but still.
Yeah. I I say let's not worry about evaluating it right now. Let's just go to the next one.
Right.
I feel confident we both know how to integrate.
Mm-hmm. Technically, oh, it goes pretty easy though.
Oh, does it?
Yeah.
Okay, well, I guess I could.
Because it turns out to be the integral from 0 to 1/2 of x to the 4th times cosine 16 x to the 5th. Because it only
Oh, right.
integrates by y, so it's just a change. It's just
Oh,
minus a. And
okay. I could do that. Okay, so it's x to the 4th, and then you integrate it. Okay, dx, and that's going to be sine 16 pi. So then you divide it by 16 pi.
yes, 1/5. It's 1/5 over the whole thing. So what's the channel for that? Oh yeah, 16 pi. My bad. I missed a couple things. Thanks for.
Okay, so what'd you get for the answer?
Um, sorry, I
Or are
was
you
back.
not there yet?
Um, I know what I got for the integral. So it's sine 16 pi x to the 5th from 1/2 or from 0 to 1/2, and it's all over 16 pi times 5.
Oh, times 5. Oh,
Like,
yeah.
like because the x to the 4th was just its bare self,
Right. So, okay, 5 over 16 pi.
all over 16 pi times 5.
Why is the 5 on the bottom?
Because
Duh. Oh, okay.
yeah,
Okay, so 16 times 5.
right.
80. Okay.
Then so sine of 16 pi over 2 to the 5th, so 32, and then minus sine of 0, which is 0. So it's sine pi over 2 is just 1, right?
Yep. So I got 1 over 80 pi.
Yeah, and 16 times 5 is 80.
Yeah.
Yeah. Yeah, 1 over 80 pi, that's what I got. So that, for some reason, they always, it's so tricky, but, you know, cool, that's it.
Okay. Cool. All right, let's go to the next one.
Oh, the next one is pretty simple. It's just,
It's kind of the same thing we just did.
technically, you can use Calc 1 with it.
Oh, yeah.
If you think about it, it's
There were a
just
lot of them that was like, find the area of this using a double integral, and I was like, or the area of the circle is pi r squared, and
right.
I'm done.
Right. One time I used the physics formula for one of the questions in the homework because it had like a hollow sphere. You try to find the moment of inertia, and I have a formula for that in physics. You substitute the mass for the density constant. It's just funny. What about 3? I want to just do that real quick.
Okay, let's do it.
I remember I got this at one point.
Let's see. I just have to look up what the formula is. Green's theorem for flux. I think that's the n sub x minus m sub y.
Right. And isn't Green's theorem just making if you have like the integral of a function over a curve, like a line integral, you can change a line integral into an area integral um over the field,
Oh, yeah, I guess that is what it's doing. Yeah.
over the
Yeah,
region.
so you end up with a double integral. Okay, the formula is the double integral of the region, and then the function that you integrate is m sub x plus n sub y.
Right. Is it plus or minus?
Plus on this one.
What is
So
that?
originally it's minus for flux, but then when you turn it into area, it becomes plus. I don't understand why, so that's all I got.
The first one will be n, so it'd be n dx plus m dy, or is it backwards?
Um, mdx minus, well, okay, wait. So there's a formula for flux that is mdy minus ndx, but when you turn it into the double integral, it's the partial derivative of m with respect to x instead.
Okay.
So you don't multiply it by dy or dx. You take the partial derivative of m with respect to x and add it to the partial derivative of n with respect to y.
Okay, that seems simple to remember. Are there any differentials on that, or is it just dA?
dA.
dA, and not d sigma. That's hurting my head.
Oh, yeah. Okay, so the partial derivative of m with respect to x is going to be 1 plus e to the x sine y. And the
Yeah,
partial derivative of n with respect to y is going to be negative e to the x sine y,
right.
which is convenient because those cancel out.
Right. Yeah. So, um, double integral over region R, 1 plus ex sine y minus ex sine y. Whoa, that's really nifty difty. What did I
What are
just?
the bounds on this?
And it's over.
The
Before
right.
it was over the curve, and now it's over the area formed by the right-hand loop of the lemniscate.
Okay,
So
so
instead of going like a line integral above this, you're trying to find like the volume under it. You can just find the area of it and
oh, I
do
remember this one. The
the
bounds
gradient.
are like negative pi fourths to pi fourths, I think, for the lemniscate.
Mm-hmm. Yeah, because we do an extra integration with the double integral, but we kind of go down a level as well with the whole grading of the gradient. It's just
Okay.
it hurts my head, but it makes sense. And so the region itself is the region bound by the curve. So now we're just trying to find the area of the curve because it's double integral over r times 1 dA. So now it's just the area of the lemniscate.
Makes sense, I guess. So then since we changed it to polar, it becomes RD theta.
Mm-hmm.
And let's see, R goes from 0 to 1 and theta goes from negative pi fourths to pi fourths. Is that what you got?
R goes from 0 to 1. I know that R goes from R is now it's like calc 2, or is it 1? It's 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 the formula from the other class now. It's
Oh no, R goes from, oh, that's where we use this. R goes from, it's the square root of cosine 2 theta, right?
yeah.
Yeah, okay. R goes from 0 to the square root of cosine 2 theta.
Um, so we use this formula on the bottom. It becomes that pretty easily because it's just RD theta. Integrate that for the first level is just 1/2 r squared d theta.
Oh, okay, I see what you were talking about. Okay.
And the second one, there is no lower bound. You know, it's just under the curve from under its bounds. You know, so
Right, okay.
the second one is just 0. So it just becomes like a calc 1 formula
Okay, cool.
where r
Um,
equals square root
use
of
Green's
cosine
theorem to
2 theta.
find. Okay. Well, okay. So we both know how to set up the integral on this one then. Um, And I think I need to go now. So.
Okay. And then, okay, so just to wrap that up, it's just the integral from angle 1 to angle 2 of cosine 2 theta d theta because it squares out and it's all over 2. And solve that, we get the answer.
Oh, okay.
Which is actually, I don't know the bounds, but the integral in the end would be just.
The bounds would be negative pi fourths to pi fourths because like the lemniscate at 0 is at like on the right side and you want to go from.
Okay.
Maybe I can.
And it's.
Draw it really quick.
And the integral at the end is just sine 2 theta from negative pi over 4 to pi over 4 all over 4. You just solve that.
Yeah, okay.
Hmm.
Does that make sense for the bounds, that little picture?
Yep, yeah, of course. And it intersects and you can find the angle. Then sine 2 theta. It's just 1 minus negative 1 over 4, so it's 1/2 is the area.
1/2?
Sine of pi over 2, because it's a double angle on the inside.
Oh, so right, okay.
2 times pi over 4, that all becomes 1 minus negative 1 is the next one because sine of negative pi over 2 is negative 1 minus negative 1. 1 minus negative 1 is 2, and that's all over 4.
Oh, it's okay.
Because of the last integration, it's cosine 2 theta. And this.
Okay, right. Because we had the 1/2. Okay.
So the answer is 1/2.
Okay, cool.
A little tricks to just solve them.
I think that sounds good.
Yeah.
Okay, is that everything? We did the quiz corrections. We went over the missed questions. That should be everything.
Yeah, we knocked it all out.
Okay. All right, sounds good.
Cool. See you next week.
Okay, see ya.